Hi, this is Tanner from Sculpt. Today I'm making this video in order to demonstrate some of the basic functionality of our product. Sculpt is a tool for creating datasets, augmenting datasets, and creating machine learning models. We're going to create a model today that is used to predict Amazon reviews as either positive or negative, using nothing but unlabeled data as input. We'll start by creating a new model. This is the model configuration page from which you can control all aspects of your model. We'll start by giving the model a name. We'll call it the Amazon Review Classifier. We also need to create a couple of classes for our model. The first is the positive class, which is green, and the second is the negative class, which is red. You can choose to have more classes if you like, but we only need two for our example. Next, we're going to upload the unlabeled data from our local machine. And if you already have some labeled data, you can upload that in this section here. Finally, we have the keywords. Keywords are important words that will be highlighted in examples while you're labeling. They'll also be used to help inform the suggestion engine, which will assist in creating the dataset more quickly. The keywords we're going to use today are good, bad, amazing, and disappoint. Now that we've configured our model, we just need to hit complete setup to create it. The first step in developing a model is to create a labeled dataset to test that model against. You can both upload labeled data to the model configuration as well as label records directly within Sculpt. On screen, you can see an example of a record that was randomly selected from the unlabeled data we previously uploaded. You can also see that the keywords are highlighted, which help draw your attention to the most important parts of the text. Once you decide which class the example belongs to, you can select the corresponding label at the top of the page here. In certain cases where the dataset is extremely unbalanced, you may need to find examples for the smaller class. This can be done by using our search feature here. In our case, we're going to search for the word bad in order to find more negative examples. You then read each example to see whether it's positive or negative and select the corresponding class here. Once you're done, hit the next button and more examples will be presented. Keep doing this process until you have at least 100 examples per class, and then we can move on to training the model. The next step in developing a model is to create a dataset with which to train that model. The interface for this is the same as labeling with one exception. You can also highlight text. By highlighting text, you're explaining to the system why it is you selected the label you did, in this case positive, and also helps to inform the suggestion engine. In addition, the suggestion engine also uses active learning to select which examples the user will annotate. By doing this, you're able to train a more powerful model more quickly. This page contains a list of rules which translates how the model is making decisions to a human-readable format and allows the user to control the model's behavior. Each rule contains 3 pieces of information: the precision, the coverage, and the pattern the rule is based on. In addition, each rule is automatically set to enabled or disabled based on how informative the model determined that rule to be. The user has the power to modify any existing rule as well as create new rules in order to insert their domain expertise. Once you've created your model, you want to ensure it's making reasonable predictions. On this page, we select random examples from the unlabeled set and use the model to classify them. This allows you to see how well your model is performing on real-world data and acts as a sanity check for your datasets. For example, if you have high stats on your test set but poor results on the random examples, there could be an issue with your test set. You can filter by class and search the text in order to find examples you're most interested in. Once you're happy with the results, you can select the precision and recall that best fit your use case, and the model is ready to go. Under the hood, Sculpt augments your training data in order to create a more powerful model. We have implemented state-of-the-art techniques including weak supervision, semi-supervision, and text editing. These approaches have been evaluated on real-world use cases and demonstrated to improve model performance. Back here on the model configuration page, you can export the model and dataset using this button and use the dataset to create your own models. If you're training a deep learning model which requires a lot of data, using our augmented dataset can save you from labeling thousands of extra examples, which is both expensive and time-consuming. Our objective today was to create a model that classifies Amazon product reviews as either positive or negative. Based on the produced graph, we can see that we've made great progress towards this goal and in a limited amount of time. If we wanted to improve the model further, we would continue to label additional examples and monitor the stats until we were happy with the outcome. For our case, though, the results are good enough. We appreciate you taking the time today to learn about Sculpt. If you feel our product could be useful to you in any way, please reach out to us via the contact section on our website, and we can set up a time to talk and better understand your needs. Thank you.